domain. So first of all, I will go through the process of STEM. I hope everybody is aware of what is STEM about. STEM is about, but still I'll give a basic introduction. And the the topic, the presentation that I'm going to give focuses on the challenges that are faced by the stakeholders in education sector, and how STEM is used, how STEM can be implemented from the basic level, and what are the gap between what we teach in school and how the industry works, because we not only work in edtech segment, we also work in product development as well. So we have seen both the technology aspects, how the innovation works at school level and how the industry level innovation works. So there's a gap between that, and why is that gap, and what can be done to reduce it, and the role of ChatGPT, because AI is inevitable, but how it can be used. So that has to be defined well when it comes to in terms of innovation. I'll we will mention the role of ChatGPT at the last. Okay, so let me share the PPT. So is my screen is visible, sir?
Yes, sir. Yes, sir.
Okay, sir. Thank you, sir. So these are the topics. What is STEM about? Current challenges faced by stakeholders, and why STEM now, and role of math and science in STEM, and experimental learning. I'll suggest few activity-based learning that can be started even today without having any components like microcontrollers and other stuff. Okay, and other stuff. So STEM is all about, STEM is science, technology, engineering, and mathematics. It's a short form of application of science, technology, engineering, mathematics, where the science and maths and engineering and mathematics becomes the solution for the problem statement. So whatever they learn at school or concepts, okay, and they'll be implementing whatever they learn to find a solution. For example, when it comes to a task, we give a task where the robot has to move 10 feet, where the mathematical concept of calculating the circumference of the tire and how many rotation it has to do to complete the distance. So this is how we implement whatever they learn, or whatever they're learning in academics. They have to apply this in solving a problem, so that they will get to know a feeling that whatever they study in school are applicable in the real life. So to give this thought, we come across a huge challenge of breaking the myth about robotics in the real world. So we do uh, get influenced by the movies about robotics, which is not true. So first we have to break the myth how those robotics movies are based, be it in India or be it in Hollywood. They make a humanoid robot. Okay, but in most of the industries, it is not the case. Okay, the form factor doesn't matter. So we break the myth of how those movies are actually made, and then how the real world robots are built. And then we should give a awareness that whatever in the real world robots are, that the same thing is converted into a small form factor, and then it is given to them. So if you give that awareness, then only the students will be convinced to learn that kind of robotics what we teach at school. Because whenever we give a robotic chassis which is similar to a car, students don't accept that as a robot. They're expecting a humanoid kind of robot. Of course there are robots like that, but at their level, and when it comes to the scope of implementing in the industry, that is quite very less. Okay, so that's now we are getting Boston Dynamics, Falcon, those kind of Optimus, those kind of robots from the companies, whereas the industry application of robots is entirely different. So first we need to break the myth and how those movies are made and what are the robots used in real life and how it can be implemented, how it can be learned while studying. So this is the first part we do. We break the myth of how the real world robot works. And then whatever they study, because the students have the feel that due to the social media and other influences, they have the feeling that whatever they study is not applicable in the real life, or they say that whatever we study are outdated, be it a school kid or engineering kid. They both feel that they used to compare the concept in the book and the concept in their real life. The point is, obviously, the whatever in the book are old, but the reason for keeping it in the same way is because if we give for let me say an example, there is a chip called 8051, which is very old, which is in the syllabus, but whatever we use are highly advanced and very improvised version of that. And people used to compare that whatever in the book is outdated, but it is not like that. If you give the recent chip and its architecture and it's working to a kid who just who's studying the first year or second year, he or she may not be able to understand it. Even the people who are working in R&D may not be able to understand the architecture of the current IC that is implemented now. Okay, so the reason for teaching the basics is to so that they understand the concepts very well and how the things works fundamentally. That's the purpose of giving the old IC and its infrastructure and its architecture as a syllabus. It's not that they want to teach the old thing. They want to understand the basics. And whatever the chip that we see now are the result of 20-30 years of R&D. Okay, so you cannot expect that to be in a textbook and that to read as deep as we read this small IC 8051 or older IC. Okay, so people used to compare that. So that's the thing we want to address it. So whatever in the syllabus are made keeping the potential of the student to able to understand it. So that's the reason they still have the same kind of syllabus. And I do agree that we do the syllabus lacks in few places that has to be addressed. So that is why the edtechs are there. Okay, so to bridge a gap between what is in the syllabus and what is in the industry. So Thinking Lab is not only in edtech sector. Since we deal with industrial projects, industrial automation projects, so we can see the difference between whatever they do in school and whatever is happening in the industry. Okay, so these are the challenges faced by the uh, stakeholders of the education system. Okay, so when it comes to students, they have the lack of practical exposure, career awareness, and application oriented. So they will be like in a mindset that whatever they study is not applicable in the real life. Why should I study maths? Why should I study science and whatever? And teachers, they have a lot of workloads. They need even if they want to implement STEM, they need guidance and they need technical skills. So these are based on the surveys and feedbacks that we took from our school. Uh, in 2020, in association with School Education Department, we conducted a webinar in implementing STEM labs in school for around 1,500 schools. And since then, we are visiting those schools in and around Tamil Nadu. So they do have labs, but they they find so many difficulties in executing the lab successfully. So when we ask them, these are the challenges they say, boss, we already have a lot of works to do. Then this STEM lab is an additional work for us. And it's not even a known thing. It's a new thing for us. So we need a guidance. We don't have any syllabus and all. The government just gave us the lab. Actually, it is under the Atal Tinkering Lab scheme that was alive from 2014 to 2019. So those labs were running now. So they said that it is completely new to us. We don't have any syllabus guidance and stuff. And most of the teachers that we have are arts based. only few engineering teachers are available. So we need technical skills. So these are the challenges faced by the teachers, even though they have STEM lab. And when we speak to the school, be it a private school or government school, they have the other challenges of they have to focus on the result, academic result, and then of and schools say that they have to invest a huge amount to have a STEM lab, because you need 3D printer, you need a robotics kit, you need a lot of electronics kit, and there is no proper syllabus to follow actually, because the robotics is an open source learning system. It doesn't have any proper syllabus to follow. So these are the challenges faced by the school. They have to focus on the uh, what is it, the properly managing the schools in terms of finance, in terms of result, in terms of other aspects. So they cannot focus on, they see that as the things, problems that has to they have to solve. Whereas when it comes to parents, they lack awareness, and they do have societal pressure of marks, and they do have financial constraints. So these are the challenges faced with the stakeholders of the education system. So we collected this data based on the interaction that we had with the schools, teachers, parents, and students as well. So we are here to solve a problem so that the STEM can be implemented successfully. The STEM concept can be implemented successfully, and then trying to solve the problem of the stakeholders of the education system. The first, we are giving trying to solve the problem for the schools. So the problem that they face are they need to focus on the result. So they see the STEM as one of the subject that demands technical skill and huge investment. Okay, and most of the things that I see, being a mentor to schools, whatever the project they do at school, we personally feel it's a repetitive. For example, they design a glass that detects if the driver is sleeping while driving. They detect any object if anything comes in front of it. They design a blind stick. uh, they design a stick for visually challenged people. So those are the projects they do at school level. And honestly speaking, there is no innovation involved in it. Of course, that's how it will be. uh, Few schools say to me as that, boss, we don't see any innovation from the school side in general. Okay, so the fact is, whatever we see in the news, whatever they do at school level are repetitive project, nothing new in that. Okay, but we do see some news here and there. In news we see here and there some innovations, but as far as we have seen it, everything is repeated. Okay, they have the kit. It's not that I'm complaining, I'm just putting the facts. Okay, so then why we need STEM lab? And another one question asked by parent actually. So whatever the technology that we teach now for a school kid will become obsolete when they come to work. Then why to learn some technology which is going to be old when they come to work? Let them learn the new technology, then why to learn coding now? So these are the questions that I face when we deal with parents and teachers. Okay, so let us figure it out one by one. So focus on the result. So for the schools, they have to understand one thing: implementing STEM and making the students to realize whatever they study in academics are relevant in real life or solving a problem. It changes their attitude towards approaching the subjects. They don't see uh, science and maths as stuff to learn, because it's a solution to the problem rather than the stuffs to learn. So that is the attitudinal change we need to bring. So STEM helps them in changing their attitude towards the subjects. So whatever they study in science and maths will be applied in STEM, so that they can find a connect between what they study and what they do at STEM lab. So doing so will result in improvement in their academics, but it takes time, it takes a lot of effort, it takes a lot of experimental failures, and then we need to guide them at each and every step. So this is how result academic performance can be improved with the help of STEM. So first we need to make them realize that whatever they study in academics are used in real life. And then many schools says that it requires huge investment. Yes, obviously it needs huge investment, but when you start, you need not invest as a whole, as everything. Okay, you can start with a very small investment, and you can see, try how it works, what is the impact that is it is creating, and you can work on that gradually year over year, rather than investing a huge amount at 1 year and then trying to pull off it. It may work, it may not work, but when you try it, a small investment like implementing only basics of coding 1 year, and then adding a webcam with internet facility, it gives power to do AI projects. So having a basic Arduino kit 1 year, it gives you concept, it gives you a chance of doing automation projects. And when you have a webcam and internet facility in your own computer lab, you need not have a new AI lab for that. Existing computer lab, if you implement, if you have a webcam and internet facility, you can do AI projects. In the next year, you can buy some motors and stuff, build robots. And the next year, you can buy 3D printer and do stuff. So gradually increasing at the by the down 3 years, you will have a complete lab. So you can start from the basic, and we are here to guide us. And no proper syllabus to follow in STEM regard. So that's why edtechs are there. So we do provide as education syllabus support to the schools. In 2020, we were in association with the school education department in this regard, where we are suggesting the um, curriculum for Atal Tinkering Lab. So still now we have that syllabus. If anyone needs the syllabus and if you need any guidance, feel free to contact us. We will assist you. We will give you consulting, so that consultation, so that you can have an idea about how it can be implemented. If you do have Atal Tinkering Lab, uh, please do let me know. We will guide you in documentation process, in proper execution of the Atal Tinkering Lab, so how it can be done. So everything we are doing now. And to the teachers, so the problems that faced by teachers are they have already a heavy workload, and they do need guidance in syllabus, and then it needs technical skills. So these are the problem faced by the teachers. So the point is, obviously they will have a heavy workload. Along with that, this, because the learning STEM needs a lot of demands more time, because you will not get the output at the first attempt. You need to debug it, you need to refer a lot of YouTube videos and stuff, you need to read a lot to solve one small problem. It demands huge amount of time. So whatever we do, whatever we suggest is, seek a technical guidance from NetTech that you know, so that they will be able to guide you to solve the problem, so that you get used to the troubleshooting process very easy. Because few of the schools have Atal Tinkering Lab, but they lack this guidance from the vendor. So due to which the lab is kept as it is. And then it needs more technical skills. What we suggest is, need not to do a big project at the first year. Just start with basic, simple activities. At the end of the session, I'm going to give a few simple activities that you can try with your kids even today. Okay, you don't need any electronic component, basic things. Okay, so these are the solution that we give. Okay, so seek a technical guidance from a tech company, and simple activities. If you don't know any edtech company, you feel free to contact us. No problem. We will guide you how it can be started. You can put it like this: like, you don't have any microcontroller, any robotics kit. You have a computer lab. Shall we do STEM? Of course, you can do STEM. Okay. So how it can be done? How, where can we start it? We don't need have much of huge investment. So where can we start? Okay. So that can be okay. Shakil. Okay. Right. So these are the things. So we will guide you from end to end process. If you have struck up any documentation process in government schemes, we will guide you. Recently, they are going to launch SDP, Student Innovation SIDP, Student Innovation Development Program. I am also the part of that ecosystem. So I will guide you. I'll mentor you the topics that they give. Okay, because whatever there is a like what is it? There is a huge potential, but it needs proper guidance. So due to the lack of guidance, the teachers are not able to pull it out. Okay, so we are here. That's the purpose of EdTech, rather than just selling their kids. Okay, whatever the things infrastructure support you have, we are here to support the existing infrastructure to a certain extent. We can do that. And parents. So parents, they do lack of awareness, societal pressure, and financial constraints. So conducting expos with STEM concepts will give awareness about the automation concepts to the parents. They do visit the STEM expos conducting in our school, and so that they will get to know about what exactly they do at school. Okay, then they will encourage their kid to involve in that. So that is how we are. That is how we can educate the parents about STEM concept, and once they get the awareness, they will be able to get out of the societal pressure of comparing the marks with the skills. Okay, those things are entirely different things. So obviously, we need marks to a certain level, and we need skills to a certain level. Okay, we need both. Whereas when it comes to financial constraints, it's not that you need to buy a robotics kit that cost few thousands. It's not like that. You can start with the simple things at home. Okay, where they learn basic science, and then there's a lot of things to learn about science with the things that you use in the kitchen, as simple as that. So whatever we use in our kitchen, using those things, you can learn a lot of science, simple things at home with a paper. So I'll give some activities that you can start doing today without even buying anything. Like, so that is how the STEM will be. So because most of the schools thinks that STEM is all about only robotics, building robots, building automation projects, coding. It's not like that. It's a uh, it's a structured way of learning STEM. Okay, but it's not only this. It's not alone, that is alone STEM. There are a lot of things to do at home where the purpose of STEM is solved. Okay, and then students, they do the lack of practical exposure. So whatever they learn in academics are applicable in the real life. So that is our role and responsibility to give the connect. Whatever they study in academics are applied in the real life. So we have to expose them to the technologies. Okay, so to do that, first we should be aware of it. Okay, so that is where the gap is. Okay, the reason for the gap is that they already engaged with a lot of works, and it demands a lot of time to learn a STEM skill. So that's why the edtechs are existing. Okay, what they do is they send their own resources who is already aware of the recent technologies, who is technically equipped. Okay, so they do solve the problems by sending the resources. That's what we do as well. So we do set labs, we do send people with the labs. There will be few labs, but they will not have a proper technical person to take the class. So we will send the technical persons. Okay, or else they occasionally need a support like faculty development program. They have faculties, they know few basic concepts, and if they are willing to learn, we will educate them. So it's a faculty development program. So whatever the requirement is, their techs are there to fill up. It depends upon their policy, they will assist you. Okay, so these things can be sorted out by giving the relationship between whatever they study for the students, whatever they study in the academics are relevant to the real world. To do that, we need a people who is aware of what is in the syllabus and what is in the real world. And here are the few activities that I suggest. Okay, for the simple STEM initiatives at your school. Okay, you need not to buy anything, any microcontroller and electronic stuff. Let's start with the basic design thinking activities. Okay, so design thinking is nothing but a step-by-step process of finding a solution to a problem. finding a solution to a problem. Okay, so we need to exercise the process of solving a problem so that whatever the experience they learn now will be helpful in future for them to solve a problem. So here comes the answer for the question that a parent asked. Whatever they study now will be old, will be obsolete when they go to work. Okay, so that's what you're also saying. Whatever the coding that we teach now will not be helpful for him, for her. They're not going to do the same code while they are at work. These two things are entirely different. Okay, there is a concept called technology readiness level. Okay, there are 9 stages. Whatever we do in school and college level, we will go to up to stage 3, prototype stage. Whereas when it comes to industry, we have to pass all the 9 stages. So there is a lot of difference between whatever the projects that we do at school and what are the concepts they do in real life. Okay, so but why learn coding now? The point is very simple. They will have the experience of logical thinking, not the syntax. Okay, whatever they type now, whatever the coding language they do know, they do type now, will not be the same exactly they will be doing in real world. It's not like that. Okay, but they will have the experience of solving a problem. Okay, the tool may differ. Okay, whatever they code now, whatever they code in future are two entirely different things, but the experience of solving a problem remains the same. Okay, the thought process remains the same. Okay, so these are the activities that you can give and what we have to follow up, because most of the schools, they do these activities and they just stop there itself. But it is not a thing to just do the activity and stop. And there is a role of teacher that we'll explain. So first challenge is tower building with paper. So we should give this newspaper to them. Okay, and tape, a simple cellophane tape. Okay, using that, we should ask them to build a strong and stable paper tower, the tallest tower among the students. So they will be given with the same amount of newspaper, for example, 2 to 3 sheets of newspaper, everybody, and one tape, one small cellophane tape. So it would cost you around 20 rupees mostly. Okay, 10 rupees for paper, 7 rupees for paper, 10 rupees for cellophane tape. That's it. This is how the most expensive thing that you can invest in this. Okay, the point is they will get to know about how it can be structured. They will know the process of planning, teamwork, and then what where it can go wrong, how to solve a problem. So these are the experience that they get. Okay, it's not the tower, it is the experience that they get. That's the takeaway. Okay, so how they planned at the first place, what is the basement it should be, how tall they can go to, and how to utilize the available resources in optimum way. So these are the things they go through it subconsciously. Okay, and this is how a problem has to be solved. The entire takeaway is, are they able to break down a bigger problem into a small solvable task? So this is the attitude we need to bring. So how big the problem may be, we can break that into a small doable task, solve one by one, and combine them, a problem will be solved. So this is how we have to move this kind of activities. Next is parachute design. It's very simple. So we need to have a small weight that can be a stone or something, just rubber, whatever, and 4 pieces of thread and a plastic paper. So this is thing simple. So we can ask them to have a design. So they will design various types of parachute, and then they have to drop it and check which one works better. When it comes to parachute design, the importance of parachute obviously everybody knows. uh, and then parachute is used in skydiving and also in satellite, in rovers. For example, the Curiosity is a rover which was landed in Mars. Okay, obviously parachute design is one of the important thing that they have to do, because it 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 enters the Mars at very great speed, and the and the rocket drops the robot from certain distance. Okay, so they need parachute for a proper landing of that rover. If you see a documentary regarding the Curiosity rover, you will understand the need of parachute there. And balloon drop challenge. So balloon drop challenge is nothing but fill a balloon with the water, and when they drop from a certain height, it should not break. So they should design a protective system to safeguard it. So these are the, so they will get to know about how a shock absorbing concept works. Okay, how the force and other stuff works. They will understand how it can be reduced, the impact of the force can be reduced. They will understand these things. And then paper airplane distance test, like it's a rocket, everybody does that. So which rockets, which design, which fold moves far distance. And then coin boat, it's a simple foil paper, and they have to design in such a way that it withstands as many coins as possible. Actually, these activities most of the schools are doing, glad. Okay, if not, you can start doing this activity. And the point is, this just stand, they just stop just seeing this output. Okay, if they build a tower paper, they just stop there itself, but it should not be stopped there. There is a role for the teacher. We need to ask questions and what they observe from the design, and put a lot of what ifs. Okay, what if this is like this, what if it is like that. So you should ask a lot of questions of various permutation and combinations, so that they are pushed to think about the science behind it. Okay, because a lot of things we do at school where we just stopped just by doing. That's not the whole thing, actually. It's a part of it. Okay, so we should ask them questions and what are the observations they made, and ask about the other what ifs and why didn't they go for that. So these are the key factors that we need to question the students, so that they'll get an idea about the thought process they are going through. Okay, you should ask a lot of questions, how it works and why did you go for this design, and what do you observe from design A to design B. You can compare the two towers of the students of two different teams, and you can ask them to review each other's. So these are the role of the teachers, so that this they will be able to understand the concept. Okay, so this is just a point to trigger their curiosity to learning, which is just a beginning. Okay, so don't stop with those activities. Ask questions. That is the role of the teacher here. Okay, because we are not going to teach anything to them. Okay, they will be just doing, we will be just observing, and we should ask them the questions, what they have learned from that. So those are the things we need to ask. Okay, by but the point is, we can do this to a certain extent. We only with these observation skills we cannot solve all the problems, okay, at the school level. So they need to develop skills to develop a system that demands the exposure to certain technologies such as electronics, embedded coding, 3D modeling. So this is where the hardware part of the STEM lab comes. Okay, because the whatever the activity that we said are thought process activity. Okay, but we cannot keep on doing only that. Okay, we need a skills that can transform their ideas into reality. So that is this is the second part of the STEM lab. Okay, so first you can start with the first. I'll send this PPT so that you can have a look at it. And then the point is, so this is the technologies used to solve a problem. If you want to teach robotics, what we honestly suggest is that the suitable age is grade 4 and above. Okay, we never
Time is 30 minutes.
Oh, okay, sir. The last side, sir. Okay, so whatever we do, these are the IoT is suitable for grade 8 and above, and coding is for grade 4 and above. Simple automation is 6 and above. So these are the things. Okay, and the last question is role of ChatGPT, because most of the people think that if you are ChatGPT, you can solve it. It's not like that. ChatGPT is just a tool. Okay, it's like a screwdriver. I should be in a position to use it efficiently. Okay, then only we can learn it properly. So these are the things that I want to share. And if you want to contact me, this is my contact number, and we are we are here to give a free consultation on how STEM lab works. And if you need guidance in adult tinkering lab, you feel free to contact us. So that's all from my side, and thank you and Jazakallah for giving me this opportunity. And thank you for your valuable time, sir. Thank you. Thank you, everyone. Thank you, sir.
Yes, thank you very much, Engineer Mohammed Niyamatullah Saab. Very effective points you have told how to introduce STEM education in the schools. It is need of the hour also. Many schools are not feeling the need of it. They don't know the importance of it, and that's why they are not concentrating. But anyhow, slowly they are picking up. So thank you very much for enlightening them on this importance. With this, the program comes to an end. Again, tomorrow morning 6:30 we'll be meeting to listen from other speakers on different topics. Thank you very much.
Okay, sir.
Subhanallah, bihamdika, ashhadu an la ilaha illa anta